Hello, everyone. How's it going? Thank you for coming out on this lovely summer evening to talk about coding. I know it's the most boring thing you can probably do on a Wednesday. Is today Wednesday?
Tuesday.
It's a Tuesday on a Tuesday night.
Next month.
See,
Yeah.
being consistent pays off. All right. I have a short presentation that I'll be going in and out of, and then I'll be showing some code. Can everyone see the code? Is it too small?
We get twice?
Yeah, I guess that'd be good. And then maybe zoom in a little bit. Does that help? A little bit better? All right. Cool. Nice. Okie doke. So let's get started. All right. So I'd like to talk about RouterFirst Architecture in Angular apps. And you might be wondering, what is that? It's nothing established because I just wrote about it in my book. So I'm trying to make it happen. So this is the talk to start that process. All right. So my name is Doguhan. You can follow me on Twitter at Uluca. And I'll be talking at Angular Mix in October. If you're interested in going, you can use promo code my last name, Uluca, and save $50 there. It'll be in Orlando. All right. And then my book is out. You can go to angularforenterprise.com to get more information on that. All right, so why are we here today? Why do we program? Why do we code? Any suggestions? Why do we do our jobs?
It's fun.
It's fun. Okay.
You get paid.
Yes. All good points. But why do we get paid? I guess to develop apps. Is that why do we get paid? Solve problems. Okay, that's I like that a little bit better. Yep. I think that's pretty good. We do what we do because we're trying to deliver some kind of value to a user. So, and doing this is pretty tough. But if you do it right, you do it consistently. You don't ship one feature in 2 weeks and then the next one in 6 months. You ship in regular cadence, and it's really difficult to achieve this consistency. We have Agile and things like that to help us set up processes to make this happen. But if we don't get the engineering portion of it right, it's really difficult to achieve a consistent pace to deliver. And then quality. If we ship with bugs, whatever we ship, whatever amazing feature we create, it's gonna just frustrate our end user, and it's just gonna cast a shadow on what we've done. So we have to ensure that everything we do is quality. So we want to deliver consistent quality value. So the RouterFirst architecture is about achieving consistent quality value with Angular, and we'll be diving into specifics of how you should try and go about developing your next Angular application so you can kind of stay out of trouble, deliver things smoothly, and create a flexible architecture so that your app can grow over time. So how do we do this? So good coding practices is golden. This is a slide from John Papa's presentation at NGConf. And these are some of their rule of thumbs that they follow. So the first one is the 5-second rule. If you put up a piece of code on the screen, the most junior person in the room should be able to understand what's happening with that code in about 5 seconds. If they can't, then that means we need to refactor that function so that it's clear. How do we make this happen? There are some further rules. We want to do one thing per file. We don't want to have 3 different things happening in one JavaScript file. Want to have our functions as small as possible, about half a screen, but you can't cheat by turning your screen. And then, well thought naming. Don't shorten variable names. We're way past the dark days of 8-bit computing and 80 character wide monitors. We're high def, 4K, gigabytes of RAM. It can support descriptive English variable names and function names. Use comments wisely. I think don't do it, because your code should read in English. So if you need to really comment something, you should ask yourself, why am I commenting on this? What's wrong with this that it needs explaining? So things should be straightforward as much as possible. So as a team, within your teams, agree on a style guide. Make sure everyone is coding consistently. You can enforce your style guide using tools like Prettier, so that before everyone checks in, it makes sure that the brackets are all consistent, the spacing is all consistent, and it's a pretty awesome tool. I also wrote about it in my book that can automate a lot of those tasks for you. All right, so what is the RouterFirst architecture? It has 7 kind of ideas behind it. So the first one is developing a roadmap and scoping your feature set. So one of the biggest mistakes that I see happen out there is a new development team on the first sprint or sprint 0 or whatever, without asking too many questions, they just grab the first story and they start developing it. But where are we going? If you don't have a roadmap, you can't iterate without having a roadmap. Otherwise, you're just taking shots in dark. So we'll be talking about how we can make this happen practically while still delivering value. And designing with lazy loading in mind. Lazy loading is an awesome feature in Angular, and it helps us modularize our application. So even if your application suddenly grows to a large size, the performance of your application at launch remains consistent because you're grabbing resources from the server as the user clicks around, uses your app. And we're going to do this at the beginning, because if we do it late in the process, then it becomes nearly impossible to pull off. All right, and then you want to implement a walking skeleton navigation experience of your application. Just, so once you have a scope in mind, once you have a roadmap, just put out all the links, all the navigation, and test it out, and see how things work well. We'll also look into that real quick. And then achieve a stateless, data-driven design. This will keep your code flexible. Enforce a decoupled component architecture. Every component should be able to survive on its own. It shouldn't depend on data coming from elsewhere. And then differentiating between user controls and components. This is also a really important thing, and it's one of the reasons why we want to do some design ahead of time, so we understand what we're going to reuse across our app. Because I've seen it in a lot of places where the same thing is just developed, 3 months apart, 3 times in the same application, and then they each have their own unique bugs and their quirks, and the usability of it varies. So we want to think ahead of time and figure these things out, so we can actually save time. And absolutely leverage the features of TypeScript, so that you are maximizing your code reuse and save time and increase the quality of your application. So in essence, the customer wants this fancy swing they explained on the left, and we just want to get to that tires swing that the customer really needs as quickly as possible. And we want to do this through delivering concrete working code. So, all right. And adding enterprise development. So doing this is difficult enough if you're just a one-man show with a client. We add enterprise into the mix, things get kind of dangerous. There are lots of things in the enterprise that can hurt you. So there's the code bases can be very large. Maintaining code can become painful over time. It can become very difficult to resolve bugs or even find how they're happening. Then you have to develop and deliver hot fixes. You're maintaining multiple branches, patches to your code. There are enterprise-wide standards. Security needs, architects, all have their, idea of own perfection. Everyone wants everything to perform at a high level. And then you have your customers with their needs. And the worst of it all, you have managers that are on your case. So when we add all these things, enterprise becomes really tough to deal with. But don't worry, you have your trusty shield, Angular, to help protect you from the dangers of enterprise level development. All right, so we can really split up concerns in enterprise-grade development into two categories. One is under the umbrella of requirements. And then the other is under the umbrella of architecture. So, in terms of requirements, we want to be able to build a roadmap, and we want to be able to know the scope of our work. And in terms of architecture, we want to achieve a flexible design and have it be performant no matter what size our app grows to. So, let's go over these one by one. So in terms of requirements, one of the best ways to get an idea of what you're dealing with is to define user roles and a sitemap early on. So I want to give a concrete example here. So I developed this app, Lemon Mart, as an example for my book. And I wanted to create a grocery store application, a line of business application that's kind of just has standard line of business type features. So I sat down and I started thinking about the first thing I thought about before I thought about any features. I'm like, okay, what are the user roles that are going to access the system? So, the first role is the unauthenticated user, the user that just lands on the site, and that's their experience. And that's an important thing to define. And an authenticated user can log into the system. That's the only thing they can do. Or you may want to be able to do other things as well, like register for an account or stuff like that. And then we have a cashier who can check out customers buying goods on the point of sale system. We have clerks who can add new items to the inventory, or they can view inventory to take stock. Or we have managers who can access all system functionality. And on top of that, they can manage the system's users, and they can look up receipts for like returns and things like that. So basically, when a manager logs into the app, they're going to get the entire app, right? But when a cashier logs in, they're just going to get one screen. All right. So this gives us a better idea of what kind of features our app might have. And it's really important to validate this with your client or customer. And then, given this information, I just sat down and built a sitemap. So for the unauthenticated, authenticated, and cashiers, so there's going to be a login page. For authenticated users, there's going to be a user profile. And then for cashiers, there's going to be a point of sale screen. For clerks, there's going to be an inventory module. It's actually, I just realized it's swapped. For managers, there's going to be a manager module with users and receipts. And then for clerks, there's going to be an inventory module with stock entry, products, categories. So just by thinking out loud about this and just putting it down on paper, our requirements are becoming more and more concrete. So this gives us our roadmap and scope in a sense. So now we have an idea of how big this app is going to be. So let's see how we can get this done in Angular. Has anyone heard of the Augury plugin? Yeah. Okay. So that's the official debugging plugin for Angular. So I highly recommend that you set it up if you haven't used it. So it has 3 tabs. One is the component tree. That's where there's a mapping of what kind of components being rendered on the screen to like a tree structure here. So you can click on those and inspect the values. Click on view source to see the source code behind the component. And then with the injector graph, we can see what kind of services are being injected into that particular component, so we can get an understanding of what's going on. And then there's a router tree. And who here is familiar with the router? Or who here is not familiar with the router? Okay, so everyone is familiar with the router. All right, so here, we have some components at the top level: home component, login component, a page not found component. And then we have some feature modules. So these are manager, user, point of sale, inventory. And you can see they're demarked as lazy. So that means at this point, none of those assets have been downloaded onto my browser. And then here at the ng module, so app module is our base module, and then I have some helper modules here, but we can see that none of our feature modules are actually loaded in here. So, all right, let me go back to here. So, once we've made a plan, we want to be able to demonstrate this to our, product owner or client, so that they have a concrete idea of what we're trying to get done here, so that we solidify our scope before we invest too much time and energy. So the second step, before we dive in, should also be to create quick mockups of what you intend to build, and these can be very simple. Doesn't have to be anything fancy. Just a simple login, a side navigation, and then a profile, the cashier's view of the point of sale system, a clerk, dashboard, inventory dashboard, listing of products. If you click on a product, being able to create a new product, categories, being able to add new products into the inventory, and a manager's dashboard, receipts, users, etc. So once I've done this, there was one thing that I noticed is that I have a user profile here that a user can view their own profile. And at the very bottom here, I have a master detail view. Also, if a manager clicks on a user, they see their user details. So this signals to me that this is an opportunity to reuse that same component. So when I design my user profile, I'm going to keep that in mind with that reuse in mind. And we'll look at how that can be done in practice. So let's get back to seeing how a walking skeleton experience looks like. So I'm going to log in as a manager here. All right. So you'll see in the router tree here, I've logged into the manager's dashboard, and it actually loaded that manager component, and you can see all the child components within that feature module. So here I have my manager dashboard, and what I did is I took the mockups that I created and I just placed them in the app itself so that users are not just looking at a blank empty screen, so that they can get an idea of like what's going to go in there. So in this case, I've only implemented one screen in reality, and here you can click on the view details. It's very simple. I can see this profile component here. If we actually click on the profile, there's like a whole form, but at the very end of it, there's like a review page before you update. So it's actually the same component is being rendered here and the other screen. And then there's a side nav. So we have these manager screens that we just looked at, and then we have an inventory dashboard with stock, products, categories, and then there's the point of sale screen where the clerk can enter their screen. So as we navigate through the app, we'll see that the router tree is kind of just all expanded now, and all the components have been loaded into memory. But if I were just the clerk, for example, actually I'll need to refresh to reset the state. Now we crashed Augury. I'll give feedback on that later. Oh, it is properly crashed. Wow. Yes, please. Okay. All right. Well, we're going to have to restart. Let me actually copy that. We can edit this part out. Let's see. Let's not get too excited. Okay, we're back. So let's restart. All right, so our state is reset, and if we log in as not a clerk, but a cashier actually, was what I meant to do. Here, now we've only loaded this one component here, and they can't really navigate anywhere else in the app. This is their role. So from a performance perspective, even if the cashiers are running on really old machines, we can optimize this single screen to work on, even really old browsers or computers, and without worrying about if we're going to sacrifice the features that a manager might need, which might be a lot of fancy graphs and diagrams and all that stuff, which may overwhelm an older browser, but by having that separation of concerns, we don't have to worry about making sure that everything works everywhere. We're just focused on this particular experience here. So let's see how this looks like in code. So we have our source folder. As a quick question, who here actually uses Angular in production? All right, about a third of the room. Who here uses AngularJS in production? All right, about another third. All right, so, and just to clarify, AngularJS is Angular 1.x, and Angular is Angular 2 and above. All right, so we have our app module here, and in our app module, we have our various helper modules. In this one case, I have an app routing module which defines my paths, and then I have a material module which brings in my Angular material components that I use, and then I have a shared components module here that actually brings in this view user component that I'm using in multiple other modules. So. And here, you will not see any mention of any of these lazily loaded modules, the manager, user, POS, inventory, because whenever we define something as an import, that's going to get immediately sucked into our bundle, and it's going to get packaged. So you will not get the lazy loading if you actually import your module. So the way we get lazy loading is by specifying a special router path where we specify the name, kind of the folder of the feature module, and then the name of the class of the module. So one is the user module. So this contains the logout screen and the profile user profile screen, and the necessary services to be able to fetch a user, and then this shared view user component. And so this is its own feature module. It declares its own services and providers, and it has its own child routes. So I don't have to worry about namespace clashes. And then it has its own material modules on top of the baseline material modules. So this is one of the reasons why we can vary the user experience between feature modules, because they can really just grab their own stuff, and they don't have to worry about downloading some big graphing library or something like that. And one of the nice things about this separation of concerns, if we have multiple feature modules, we can actually assign different teams to a feature module, and they can work simultaneously in the same project repository without clashing with each other. So that's a real benefit for parallelizing workloads. All right. So just to bring it home, and then has anyone used the Angular CLI component generation feature. Okay, a lot of head nods. So this is basically an exercise in using the Angular CLI to just generate your empty components, just building that walking skeleton experience, just wiring everything up, wiring all the routes together, putting in some provisional URLs and links, just populating your toolbars, your side nav, and just creating that initial experience. And that's a really powerful thing once you've created that, because then it gives your client or your product manager, project owner, whatever, a concrete idea of this is how things are going to look like. And then it becomes much easier to fill in the blanks, rather than every step of the way just wondering, how are things going to fit together. So, and let me show real quick in my top level app component how the side nav experience is defined. So I have a material toolbar here that defines the top toolbar of the application. And I have an authentication service that is defined. And this authentication service can tell me if the user is logged in or logged out. And I can kind of set this authenticated status to a Boolean that I can then use to show or hide my icons. And then there's the side nav container. This is actually, it uses media queries, so it's responsive. And let me show really quickly how that works. So here on a big, desktop style screen, you can see it's actually, coming in from the side and pushing the content to the side. But if we go into a more mobile experience, then it becomes more of a layover experience. So that's how we can kind of work with components to make them responsive with these media queries. And then, something to watch out here is this is a kind of a simple template, and this isn't something that's going to change very much at all. But something that can change more often is the contents of this menu. So, and this is our very top level component too. Like, we don't want to change this a lot. We want this to be as stable as possible through our development cycle. So that's why I actually implemented the contents of the menu as a separate component, because that can change quite often. It's okay. But it's isolated, it's its own thing. And it's very simple. So it's very, there can't be a kind of a mistake happening that potentially messes, the root level component of our app, and then break things for all the other people that might be working on our team. So here, from a linking perspective, we're actually using the name of the feature module, and then the name of the child route in there, and then we're using active link tracking. So when you click on them, it will actually. So in this case, we're getting you don't have the permissions to view this resource message because we're just a cashier. So if I log back in as a manager, so you can see there's like a little, it's highlighted, but also a little bar here that kind of keeps track of the active link for us. And these are convenience features that are all built into Material, so they're quite easy to get it working, and the router. All right. So once we have our walking skeleton experience. We're kind of getting in a good shape. So we wanted to differentiate between user controls and components. So any ideas about the difference between a component and a user control? Any guesses out there?
Is it the directives and components?
So, so that's a very challenging terminology, I want to say, in Angular, because everything looks like a directive, and that was a very that was a term that was used a lot in AngularJS, and now everything is referred to as a component. But in a sense, so the difference is, for example, date input entry. That is a user control. That is something that's highly reusable that can be applied in many different places. Whereas a component, that is defining, a portion of a screen. There are multiple components that we're looking at here. We have the app component, we have the menu component, we have the manager's dashboard component, and then we have the user component here. So they more so describe kind of segments of your application that present some kind of data or allow for some kind of user interaction, whereas a user control is a highly specific thing that's not really tied to the functionality of your app too much.
Recently, I came across this other component type called web components.
Mm-hmm.
Some distinction?
So web components are, so right now when we write an Angular component, we can only use it in Angular. Web components is a way to compile your component in a manner where you can take it and use it in any language or any framework you'd like, or even just a plain HTML page. So that, that technology, I predict, will mature about this time next year with the browser support and Angular support really coming in. So that's a different thing, but that just unlocks your Angular code that you're writing. It just unlocks it so it can be used anywhere.
So can we do it the other way around, a jQuery component if I want to bring it in? Can I make it as a web component and bring it in, or do I have to just wrap jQuery?
Yes. Yeah, you can. Yeah.
They introduced it as part of V6. Actually, this is what I gave my talk on last month.
Yeah.
Angular elements. So it's basically using the web component API to ship your Angular component so that it could be reused in different apps. So they are starting to introduce that functionality into Angular.
It's just right now, like when you do that, you have to also pack in the entire Angular framework along with your user control. So if you're just shipping like a date input component, you're shipping the entire Angular framework with it. But they're going to improve it such that the basic Angular framework is going to become only 3 kilobytes. Right now it's like 140 kilobytes or something. And the browser support is a little bit iffy at the moment. So about next time this year, we'll be talking about a lot more interesting things. All right. So, okay. So we want to identify those types of user controls. So if we have some custom business logic of entering a data particular way, like for example, some companies have their own way of inputting addresses, and that's a very common thing that can be repeated. Like, is this thing? Are you going to have like 5 different address entry in your app? Like, you want to know this ahead of time, because if you do have 5 different, then you want to invest the resources to turn that into a user control that you can then share within your application, 5 different times. But if you just have it once, just code it normal, as a component and move on with your life. No need to make it reusable. if something exists out there, of course, don't reinvent the wheel, don't reinvent your date input unless you have specific business needs where you must reinvent that wheel. And then there's also Resolve and Auth Guard. So we saw the Auth Guard in action there. And I want to show how that is enforced. So for example, in the manager routing module, my components have a can activate hook, and then and that implements an Auth Guard that I implemented. So under auth, I have an Auth Guard service, and here what it does is given the can activate hook, it calls this function check login, and this actually uses my auth service that I use everywhere else in the app. And this check login, what it does is check to see, does the role match the expected role, and is the person currently authenticated, or are they not authenticated? And then if they're not authenticated or the role doesn't match, then we can actually pop an alert. So for this purpose, I have a UI service for things like just showing alert messages, etc. Because, and I'm trying to see where my UI service is. So like, for example, showing a toast message or showing a dialogue, these are routinely, these types of interactions are triggered during like the execution of some code logic. So we want to make it as easy as possible to inject these little things into our workflow without really bringing in the entire complexity of importing all these things and setting up all these default ways of how a dialogue component should look like. And there's like a whole template you have to define for it. So imagine you're copying and pasting this code every time you want to show an alert. That's a nightmare scenario. So you want to be smart about how you reuse your code here. And in this case, if the person is not authenticated, we can even call the router and send them back to the login screen and ask them to provide their credentials. So, and that is a user convenience feature. We just don't want to tell a user, oh, you can't do this, you can't do something. We either don't want to show it to them, or we want to send them to the right screen so they can do the right thing, so we don't frustrate them. All right, and then there's a Resolve Guard, and that's pretty cool as well. So I have a user Resolve Guard implemented. So once again in the manager routing module. So I have this detail page here, which works with the view user component, and then that has a Resolve Guard implemented, which will use the user resolver. And that is a very simple thing. All it does is implements the resolve hook, and then it calls the user service to get the user, given the user ID that was provided in the route parameter. And the benefit of that is, in my component, I don't have to write a whole bunch of, I don't have to inject my user service here and then get the route ID and then call the get function and then deal with all the asynchronous stuff that happens with it. When my component activates, that data is actually already ready for me in this route.snapshot.data, the user variable that's stored within it. So this is pretty amazing in terms of even being able to reuse your fetch code in Angular. This also really simplifies the way you write your components, so you don't have to deal with that boilerplate of loading the data every time. And yes, in your components, each component should be loading its own data every single time. you shouldn't be passing around data from component to component, because that introduces state to your app that couples your components. So these route guards, resolve guards, auth guards, and user controls, they buy us flexibility, so we can reuse things without worrying about breaking things. All right, so from an architecture perspective, so we want to design with lazy loading in mind from the get-go, because it's really difficult to make it happen after the fact. But we also want to use auxiliary paths as much as possible. So what's an auxiliary path? So I have this user management screen, and the user management screen has a very simple template. It has a master and a detail view. So in this case, this table is the master here, and then once I click this button, this is the detail view. So by doing this, I can, from the router, I can control what gets rendered in which outlet here. So we have a master router outlet and a detail router outlet. So if we go to a router, we can see that by default, the master outlet will be rendered with the user table component, and then the detail outlet will be rendered with the view user component. So the benefit of doing it this way is if I have different types of records in the table that I'm showing, for example, users and inventory mixed in the same view, I can actually just through the router, I can say, hey, in the detail, now render an inventory component. And I can control that through links. So let's look at this user table, that view button there, and see how that actually implements that linking. So right here, I have that view button, and I'm defining my router link, and I'm saying, go to the path managers/users, and then I'm saying in the outlets, the detail should be the user route that's defined here, the path user, and then the ID should be user ID row.id. So it grabs the particular row's data, gets its ID, and then just triggers this route. And that does all the hard work because we implemented that resolve guard, that grabs that row ID, that user ID from this route, and then it fetches the data for me, and it renders things correctly. So if I had a different view button here, that I could have defined a different component, like an inventory component, where the path of it is inventory and the outlet is detail. I could easily have another button here that says, view inventory or something, and then we can basically orchestrate how we render our components just through the router. And this makes late design changes or late user experience changes in your application really a breeze to make. Your manager can come to you and you're like, hey, we need to change how the entire app is structured, and you'll be actually like, yeah, no problem, let's do it. How much do you want to change it? So that actually happened to me earlier this fall, and I was actually able to remix the entire UI just by changing the routes. So that was really cool. So with lazy loading, we get that performance because your initial landing experience is always going to be really fast. And then with router outlets, auxiliary paths, we get flexibility. All right. And the next thing is you want to define your data anchors to achieve a stateless data-driven design with behavior subjects. So in all of my components, they use services to exchange data, but we don't actually store that data anywhere. So the way that works is every single service I have implements a behavior subject. So in this case, this implements a user interface. How familiar are you with TypeScript interfaces? So. Okay. So this is the absolute best thing that you should be using because this defines the anticipated shape of your data without actually implementing anything. So then you can also have a class user that implements the interface IUser. And in this case, the benefit of doing this is I can have calculated fields like full name, where it will grab first, middle, last. You don't want to do this all the time in your application. You just want to do it in one place and do it right. But the problem is you don't want to pass this class around your application because that once again introduces state and side effects to your application. Because what if one component changes something in this class unexpectedly that might break something else in the application? So we always want to create these interfaces that just represent data, and we want to pass those around. And let me just really quickly in this view user component show the difference here. So in this case, we're getting an IUser, and then what I do is then I actually pass this interface into a build user function that will build the user class for me. Because in this particular example, I'm actually using that full name. But it's okay to do this, but within the confines of that component. So we don't pass the class around, we just pass the interface around, and it's okay to rebuild that class every single time. It's a little bit of an overhead, but it really avoids a lot of headaches that can be created by passing those objects around.
So is best practice to define the interface and the class in the same file?
For the most part, I find that to work the best. Otherwise, what you end up is either too many files, because then, or if you try to put like all the interfaces in a single file, then that grows really big, and then it becomes, tough to, hunt things around. So yeah, it's a good practice to keep them together. So yeah. Who is familiar with behavior subjects? Okay, a few hands. So behavior subjects are great because they need to be initialized with a value. But once they're initialized with a value, so initially this could be like an empty version of your object. But you can implement, if you cache data in your local storage, you can actually pull things from your local storage. So in this case, I'm actually loading this user from the local storage. So for example, if the user just half completed their form, but they didn't submit it, or if an error happened during submission, I actually just throw that into the local storage and then pull it back up so they don't lose their data. But due to the nature of Angular, everything is happening asynchronously. So it becomes really difficult, really challenging with multiple components rendering on the same screen. Like, for example, in this screen, there are so many components, and each of these components could have the user's name, right? It can be, hello Doguhan. One of them could be hello Doguhan. The other could be, Doguhan's dashboard. And then Doguhan's date of birth or whatever. So it becomes really challenging to try and synchronize all of those, almost impossible. So this is one of the reasons we use behavior subject, because it only retains the last value of that particular object. So every component, as they load, they all subscribe to the value of the current user. So at whatever point in time they subscribe, first you're guaranteed to get a value because you have to initialize it with a value. So if you initialize, you get the empty value, and then half a second later you get the real value. What happens is then the behavior subject pushes the update, and let's say 2 of your 5 components have rendered so far. So those 2 components will display the latest value, and then let's suppose a second later 3 other components render. They will grab that value, and at any time in the future, if one of the components updates that value, all 5 components will get the latest version of that value. So it's a great way to decouple your components from each other, because that data can flow asynchronously across, but you're always guaranteed to get the latest version of that data. So that's a great technique to keep your components decoupled, and this buys you great flexibility. And yeah, so through the resolve guards that we already discussed, and through the behavior subjects, we essentially enforce the decoupling of our components. And by having done this, we really ensure that our application can scale without buckling under its own weight, without getting too complicated, because everything is as flat as possible. Everything is independent from each other. And then finally, we want to become familiar with how classes, interfaces, enums, and validators and pipes work in Angular, because we want to leverage the dry principle. Don't repeat yourself. So a great example of this is I have a user profile. And this is the last example that I'll be showing. So in my user profile, another quick thing is in Angular, there are 2 different types of forms. One is template-driven forms, and the other is reactive forms. Is anyone familiar what the difference is? Okay, so the template-driven forms are what you're used to with AngularJS, with the ng model, etc. And reactive forms are more defined in your TypeScript code, and the behavior of it, like which value binds to which field, etc. All that stuff is actually set in code here, and we can even subscribe to various value changes in our code, so we can actually implement different behaviors of the form in code. So this avoids a lot of back and forth that you have to do between your HTML template and your view model code here. And best of it all is anything that you do here is inherently reusable. So one example could be, so normally the validators are attached to fields in this manner, validators that required. But the thing is, I have lots of text validation that's happening. So what I did is I actually created a class in validations here, and I actually created arrays of these things. So for me, required text validation is optional text validation rules plus required. So what's optional text validation rules? Optional text validation rules are, it needs to be minimum length 2 and maximum length 50. So these are just arrays. We're just concatenating arrays. It's really simple stuff, but it really makes it a great experience to apply these validations consistently across our code base. So if we look at this profile component here, we can see that instead of having like 3, validators required, min 2, max 50, and over again, do that over and over again, we're just reusing the same piece of code that we imported from that outside library. And if we want to take it further, if we're doing address all over the place, I can actually export this particular form group and reuse this exact same configuration in other forms. It's just, at this point, it's just code. It's just passing values around, arrays around. So it becomes, really unlocks lots of possibilities to reuse code. And we want to reuse as much code as possible because that keeps us out of trouble. All right. So yes, with Angular, your trusty shield, you can protect yourself from the kind of treacherous dangers of enterprise development. And that's my talk.